Okay, today we're going to be talking about minimum sample size for means. Before we do that, yesterday we had talked about calculating confidence intervals for means. I did not show you the calculator function because I wanted you guys to get familiar with the formula first. But now that hopefully you have seen that formula and are comfortable with it, you can do those questions in your calculator. Here are the 3 steps that you need to do within the calculator to get to the area where the calculator function is. You press Stat, right arrow over to Tests, and then it's option number 7, Z interval. So this is an example that we looked at yesterday, guys. I'm just going to redo it in the calculator. So over Stat, over to Tests, and it's number 7, Z interval. The calculator is going to ask you, do you have data or statistics? We're going to highlight statistics because we have the mean, we have the standard deviation, so on and so forth. Let me highlight that stats. Okay. So then the calculator is going to ask you for the values of the standard deviation, which was 2.3 for this example. It's going to ask you for the mean next. The mean was 32 for this example. And then N, the sample size was 40. It asked us to find a 90% confidence level. So I'm going to change that confidence level to 0.90 and then calculate. It is then going to spit out the values for the confidence interval for us. So we noticed that 31.402 and 32.598, that's the first line that the calculator gives us. It also tells us what mean was used to calculate that and the sample size. So basically, guys, if I'm using the calculator, the only thing I have to write out is the disclaimer or the interpretation sentence. So I would say, I am 90% confident that the true mean time spent is between 31.402 and 32.598 minutes. We did that example yesterday, but again, I'm just showing you the calculator function. Okay, for today, we're going to be calculating minimum sample size. So if we take a look at the confidence interval formula from yesterday, this example or this formula is going to be derived from anything that's after the plus or minus. Anything that's after that plus or minus symbol is called the margin of error. So if we solve this margin of error for n, you would get this formula. N equals the critical value, z alpha over 2, times the standard deviation, sigma, divided by E. E stands for the margin of error. That whole quantity is then squared. That is going to give us the minimum sample size that we would need for a particular research or study. All right, so basically when a researcher goes to do a study or an experiment, they are going to waste time, money, resources if they pick too big of a sample, or even worse, maybe they collect too small of a sample and then they don't have reliable data. So this minimum sample size formula is used before they decide to do their study to know how many people should they collect data from. All right, so let's take a look at our first example. It says a scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From a previous study, the standard deviation of the depths measured was 4.38. Okay, so picking out the important information from this question, they did give us a confidence level, 99%. The critical value associated with that is 2.575. It says they want to be accurate to within 2 feet. So that's our error, or our margin of error, E. And then the last piece of data that was given was the standard deviation, 4.38. So that's sigma. Looking at the formula, N equals Z, 2.575, times sigma 4.38 over the margin of error, which is 2. After I do that, I'm going to square that whole entire value. Okay, so going over to the calculator, guys, I'm going to plug in 2.575 times the standard deviation of 4.38. I'm going to divide that by 2. And then my very last step is to square that whole value. I get 31.8. Now, this is the minimum sample size. So I cannot round that down. So I always want to round these values up to the next whole number. So my minimum sample size is 32. So I have to collect data from 32 samples. I could always do more, but this is the minimum. All right, we're going to take a look at another example together. So here it is. A teacher wants to estimate the average time spent on homework in her class. She wants to be 90% confident that the true mean is within 10 minutes. The standard deviation is known to be 20.5. So picking out the important information from the prompt, we were given a confidence level of 90%. That critical value is 1.645. The mean has to be accurate to within 10 minutes. So that's our error. And the standard deviation is 20.5. So that's sigma. N equals our critical value of 1.645 times the standard deviation of 20.5 divided by our error, which is 10, and we square the entire value. Okay, calculating that, I have 1.645 I'm multiplying that by 20.5, dividing by 10, and then squaring that entire value. I get 11.3 or 11.4, but remember we always round that up to the next whole number. So I need a minimum sample of at least 12 students. Okay, this next example, guys, is a U-Try. So take a look at this one, see if you can find the minimum sample size needed. Pause the video, and then I'll be back with the answer in just a moment. All right, I went ahead and identified the values in this prompt. 95% confidence is associated with a critical value of 1.96. The error is 2, and the standard deviation is 8.9. Plugging those values into the formula, 1.96 times 8.9 all over 2, and then the entire thing squared. We get 76.1. Remember, we always round that up, so we need a minimum sample size of at least 77. All right, everybody, post any questions that you have on the discussion board.